Okay, I want to explain electrochemical cells. Electrochemical cells are of two types: a galvanic cell, in which a chemical reaction is used to produce electricity, and a electrolytic cell, in which the electricity is used to drive a chemical reaction. Now, in a galvanic cell, you have two half cells created by putting, for example, a metal electrode in a solution of that metal's ions. So we create two half cells like so, and we put two different metals into solutions of the two ions. So let's say we've got zinc metal here in solution of zinc 2 plus, and copper metal over here in a solution of copper 2 plus. Now we link the two half cells with a salt bridge. The salt bridge just contains pardon me, an electrolytic solution, one that won't react with the anions. So this would be, say zinc nitrate, copper nitrate, and this could be potassium nitrate. It won't react with either substances. Now, in the galvanic cell, what happens at the this electrode, the zinc electrode, because zinc is more reactive than copper, zinc metal produces zinc 2 plus 2 electrons. So the zinc comes from the electrode, dissolves into the solution of zinc 2 plus, and that leaves electrons. Now this is occurring at the anode. Anode is always where oxidation occurs, and this is oxidation reaction. Right? So we can label this as anode and oxidation, and because the zinc is releasing electrons, that makes the anode negative. At the cathode, over here, we have reduction, and reduction involves the copper 2 plus ions plus 2 electrons forming copper metal. So over here, the copper 2 plus takes electrons from the electrode and makes copper metal. That makes this electrode positive. Now if we connect these electrodes with a wire on the outside through a meter or a light bulb or something like that, then electrons flow from the negative anode to the positive cathode and allow the reaction to continue. In the salt bridge, this is the internal circuit. The beakers and the salt bridge, the two half cells on the salt bridge, are the internal circuit. What happens is that anions move towards the anode and cations move towards the cathode, and that allows the charge to flow. So electrons flow down into the cathode. The charge carriers in the solution carry that negative charge through here. The charge of the two beakers remains neutral and uncharged, and the electrons complete the circuit. And this occurs until you'd run out of the copper 2 plus ions in solution, or you'd run out of the zinc electrode, and then the cell has gone flat. Now, in the external circuit, electrons always flow from anode to cathode in the external circuit. In the internal circuit, what you have is anions go to the anode and cations go to the cathode. Okay. Now, in an electrolytic cell, we start off with the battery, because the battery is used to drive the reaction. Okay. The big side of the battery is positive, the little side of the battery is negative, so it looks like that. Now we connect that, for example, to two inert electrodes, and for this example we'll put it in a molten solution, so a liquid solution of sodium chloride, which has sodium ions and chloride ions in it. Now, in the galvanic cell, it was the reaction that made the anode negative. In the electrolytic cell, it's the cell that makes the anode positive. This is still the anode, but it's now positive, not negative, because the cell has made it positive by effectively sucking electrons off it, like so. So this is positive. It attracts the anions, the chlorine ions, which lose electrons to the anode. So that's oxidation again. So the reaction is 2Cl minus goes to Cl2 plus 2 electrons, like so, and chlorine bubbles off the anode. So it's still oxidation at the anode. At the cathode now, remember, the cell has made it negative by pumping electrons onto it. So the sodium ions are attracted to the cathode. And when they're attracted to the cathode, the sodium ions gain an electron to become sodium metal, like so. So the sodium metal deposits on the electrode. Now, in the external circuit, the electrons still go from the anode to the cathode, the same as they did over here, except over here it's the cell that's causing the electrons to go from anode to cathode, not the reaction. And internally, anions, that's the chloride ion, still go to the anode, and cations still go to the cathode. Okay, so if we now compare the two, galvanic and electrolytic, okay, what are the same? Well, oxidation in both occurs at the anode. Oxidation always occurs at the anode. That means reduction always occurs at the cathode, in both. Okay, they're the same. Anions, they go to the anode in both. And similarly, cations in the internal circuit go to the cathode. In both. Right, so these are the same. Oxidation and reduction both occur at the same electrodes. Anions and cations both go to the same electrodes. And in the external circuit, the electrons go from anode to cathode in both cases. Now, you can see that here. The electrons go from the anode to the cathode under the effect of the reaction in the galvanic cell, but under the effect of the electrolytic cell, in the electrolytic cell, they go from the anode to the cathode driven by the battery itself, by the power source. So those three things are the same in both cells. Now you'll see on the net, if you research this on the net, you'll find that a lot of sources get this wrong. Those three things are the same in both cells. What is different in the two cells is the charge on the electrodes. In the galvanic cell, the anode is negative. In the electrolytic cell, it's positive. In the galvanic cell, the cathode is positive, and in the electrolytic cell, the cathode is negative. So that's the comparison. In both cells, that's different. In both cells, oxidation occurs at the anode, anions move to the anode, and in the external circuit, electrons move from the anode to the cathode. Now you need to be able to recreate these diagrams and label them with, I've forgotten a bit here, this is the cathode, and reduction occurs at the cathode always. You need to label the salt bridge here. You need to be able to draw and label both examples.